Hi everybody, so I'm really sorry that I was not able to make it for yesterday's tutorial and for Tuesday's tutorial section. I wasn't able to explain the question 3 really clearly and which makes some of the students really confused. So in this tutorial video, I will re-explain everything clearly and because I believe the solution have been posted on Blackboard and most of you guys have already seen the solutions. So here I will introduce a second solution by my own and for your reference, right? So in the exam, if you don't understand the first solution by the solution manual, you can use my methods. Okay, let's jump into the problem 1 directly. So if crank AB is rotating with an angular velocity of omega AB equal to 6 rad per second and determines the velocity of the center O, which is center of the gear, right, center O of the gear at the instant shown. So for this question, we can notice that there is a preconditions, say at this instant, at the instant. So this is the condition when you can use the instantaneous center. At the instantaneous center, there's no velocity, there's no any acceleration at the instant. So that means you can see the instantaneous center is stationary, right? Okay, so let's go to the solution. So first step, we have to draw a free wheel diagram like this. Because all the known condition is about the AB member, so we have to do something for the AB member, right? So first step, we have to get the velocity of VB, because after we got a VB and then we observe what we have in the questions and we find the BC is a horizontal, right? What does it mean? That means if you have the VB, which is perpendicular to member AB, right? VB is perpendicular, right? And we can know the angle between the velocity B, VB, and member BC because BC is horizontal, right? And then that means the VBX, which is the velocity of VB in x components, is equal to VC at this instant, right? Only at this instant. And then after we get a VC, we can make an instantaneous centers, which we have known it is the contact point between the gear and the rack. And at this instantaneous center, we can draw something like a triangle. And remember this triangle, this will be the second solution I will show you for the next two questions, which you didn't see it in the solution manual, right? So this triangle, we can find that the VC should be twice of VO, and then we will prove it in the in the solution later, right? And then we can use the VC to get a VO, and then we done the question. So that's the logic of the question, of how solving the question, right? So now we have to get a VB, and VB is directly just equal to omega AB times RAB, right? So it is 6 rad, which is omega AB times 0.4 meter, and then we got 2.4 meter per second, and you have to know the unit. Don't get it wrong. I've seen many students in the midterm exam, the question asks for the unit for foot pound, and they use Newton meter, right? And VBX is equal to 2.4 cosine 30 degree. Why it is 30 degree? Because BA and the ground forms a 60 degree angle. That means you draw an imaginary line that goes through B point, and then you know the angle of this imaginary line and AB here is 60 degree, and because this perpendicular is normal, is 90 degree. So 180 minus 90 minus 60 here will be 30 degree, right? And then it is 2.4 times cosine 30 degree, and you get the VBX. All right, so because the rack is stationary, so we let the point D as the instantaneous center. So here is a point D, right? And it is instantaneous center. And The D point is the contact point between the gears and the rack, and at this instant, CD can be seen as rotate around point D. Right? You can see like CD, this diameter of the gear, right? The whole diameter is at this instant. We can see it as rotated around the instantaneous center, right? It's like that. And so we can have, so we can see, right? So we just make this graph CD and put it here, right? Now this is the rack, and this is the diameter of the gear, right? This is diameter, this is no radius, and this is like an imaginary trace of diameter CD that will go around D point, right? So because DO is half CD, right? Radius of the gear is half of the diameter of the gear, and then that means the velocity at O point should be half of velocity at C point, right? Because CD is 2CO, so velocity you have the relationship like this, and because VC is 2.4 cosine 30 degree, and you can have VO equal to half VC, and which is 1.039 meter per second, right? This is my own solution, and this only work because we have a really special case, which is a simple case. We have the BC member in a horizontal direction. That actually simplifies the question, and we can solve it by simply use one instantaneous center. But in the solution manual, we notice that there is another there's another way you should do it, right? You have to find the instantaneous centers of the member BC, because the member BC also rotates along with the gear. So it also has its own instantaneous center, and you can use this instantaneous center to get the velocity at O point as well. But for this case, I think my solution is okay. And if you have the BC, maybe like BC is not horizontal, it's like this, or it's like that, it's tilted, and you have to find the other instantaneous centers to find the solution. All right. So let's get to the second question. At a given instant, gear A and B have the angular motion shown, right? Sorry, I draw it a little bit messy, but you can see that, right? You have one gear, and this two gear is called a planetary gear, and which is gear C, right? Two gear, all these two gear belong to gear C, and gear B is a ring gear, right? Gear A is sun gear. Okay. So at a given instant, gear AB have the angular motion shown and determines the angular acceleration of gear C and the acceleration of its center point D, right? D is just a D point, it is not a gear. At this instant, so you can use instantaneous center again because you notice the sentence at this instant. Note that the inner hub of gear C, gear C is a mesh with gear A, and its outer rim is in mesh with gear B. Outer rim is here, inner rim is here, right? So we just say this is inner gear C, this is outer gear C, so I will use maybe just like CO or CI here, maybe, right? And again, I believe you have already seen the solution manual, but I still solve it again here and explain it more in detail than the solution, so you can understand what happened, right? So this will be the free body diagram, right? And the outer, the inner hub of gear C is a mesh with gear A, which we noted as P prime point. It is the contact point between gear C and A, right? This what do you call it? Dash line is stand for gear A, right? The trace of gear A, and its outer rim, right? The C outer rim is contact with gear B, which we noted as P point, right? P prime, P point, P prime. All right, and uh, first of all, we have to know we can know the because the question asks for the angular acceleration of c, so we just get acceleration at these 2 points first, right? These 2 points are not instantaneous center because they have acceleration. Instantaneous center will locate somewhere between this connection line, right? P prime is in between, but so far we not really sure where it is, right? So AP prime is really easy. Is equal to alpha A times RA. But remember that because your gear C is rotating in this way, right? So at the top of the gear C, it rotates like this. So the velocity is going to the left, and that means you should have a negative sign here. But if you don't really understand why it's negative here, you can also look at the gear A because gear A, right? It is clockwise. So by right hand rules, it is negative angular velocity. So acceleration, right? So it should be negative alpha A, right? And it's equal to negative 8 times 5, right? Negative 8. This is alpha A times 5 inch, right? So now we can get AP prime. This is a linear acceleration. A linear acceleration at a p prime point is equal to negative 40 meter per second square. No, sorry, it is inch per second square. Sorry. And same thing, AP equal to alpha B because B is rotated counterclockwise, and then you have positive alpha B, and it is alpha B times RB equal to 6 times 20, and it is 120 inch per square second. Okay? So now, we just you just neglect the whole geometry of the gear C, right? We just focus on this Z shape free body diagram, right? This Z. And we move this Z to here, right? We make a imaginary circle trace of P prime, right? So this member, as the time going, and it should rotate around P prime point. But however, P prime point has a linear acceleration going to this, and P point have another linear acceleration going to the right. So that means you have a balancing, like in the last tutorial I explained, it's called, I prefer to call it balancing acceleration. And there should be a balancing acceleration to cancel out the effect of the AP and make the linear acceleration at point P equal to AP, right? This is really similar to last situation, the situation in the last tutorial question 3. I have the paper like this, right? So imagine that this is the P point, and this is the P prime point, and this is the P point, right? So you have AP prime, you have AP, which is like that, okay? So we just move this one, the whole 15 inch, right? Even though the center of the gear is D point, and the radius only 10 inch, but PP prime is 15 inch. So here should be 15 inch rather than 10 inch. So it rotates with a radius of 15 inch. Right, so after we get this, it's easier to understand. So now we have AP equal to AP prime, right? AP equal to AP prime plus the relative acceleration, which I prefer called balancing acceleration, AP P prime, right? So it is 120, which we got it above here, and it's equal to negative 40 from here, right? Plus alpha. It is noticed that, right? Because they share at this instant, anything along with this this line will share the same angular acceleration. So this just notated as alpha rather than alpha p or alpha p prime. They are the same, right? This is just alpha. So alpha at this instant times the RPP prime, right? So RPP prime is 15 inch. At this instant, they have the same angular acceleration, right? So it is equal to negative 40 plus 15a, because it's 15 inch, 15a, 15 alpha. And then we can get alpha equal to 10.67 rad per second square. And at this instant, alpha d, which is the alpha at the d point is lying also on the pp prime radius. So alpha d equal to alpha, because at this instant the angular acceleration, they share the same angular acceleration, right? Since they share the same IC, right? And D is fixed with gear C, because D point is center point of gear C. So alpha equal to alpha D equal to alpha C. So this is the solution for the first question, right? It asks for the angular acceleration of gear C, right? And it is 10.67 rad per second square here. Okay, so now we have to get the linear acceleration. If it doesn't tell you whether it is linear or angular, we just defaultly think it's linear acceleration, right? Linear acceleration of its center point D at this instant. So when we talk about linear acceleration, we have to be cautious, right? We have to be cautious. After we get the linear acceleration, which is showing here, it should be noticed that it is just in transverse direction. So linear acceleration, we also have to consider the normal components of the acceleration, and then we sum it up by the square root, and then we can get a resultant acceleration at D point, right? So at D point you have transverse acceleration and normal acceleration. Okay, so to do that, because now we know the angular acceleration at C point is 10.67 rad per second, so we can just move dp, this 10-inch line, and make an imaginary trace circle like this, right? This is dp, it is 10 inch here, and they share the same angular acceleration, which is alpha c, right? And then you have ad, maybe in this direction, we didn't know yet, right? We don't know yet. And ap is in this direction, right? Which we already know. So we have the second relationship, alpha p and alpha is ap, as linear acceleration p is equal to ad plus alpha times r pd, which is 10 inch rather than 15 inch, because we just use 10 inch here, right? So 120 equal to ad plus 10.67, which we already know is alpha c, times 10 inch, and then we know ad equal to 13.333333 inch per second square, right? Unlimited 3. And from this point, I would like to introduce my second solutions, which is purely by geometric approach. So you don't need to worry about whether you have the balancing by 15 inch or 10 inch, whatever, right? Remember the where is the solution for the first question? Oh yeah, remember the triangle in the first question? Triangle here. Remember this triangle? And we know it because D point is stationary, so it is 0, right? The acceleration is 0, right? So now what we have to do is doing the same thing, but rather than just one triangle, we now make it 2 triangles, but they are similar triangle. At O point, which is the actual instantaneous center between P prime, right? I say instantaneous center will lie in between PP and PP prime point. And then at this point, we don't have any acceleration, right? The horizontal, you just draw a bunch of horizontal lines within these 2 triangles, and then the length of this horizontal line will be the scale length of your acceleration, right? They follow the linear relationship. Remember what I say here, they follow the linear relationship for transverse direction. For normal direction, it is not. You cannot use these methods to get normal direction, right? And this sentence is really important in the next question. And now we have AP prime, which you already know is -40, so that goes to the left, and AP is 120 goes to the right, and then you have to draw a Z like this, and we know PP prime is 15 inch, right? And then we connect the tail of the arrow, the head of the arrowhead of AP prime to the arrowhead of AP, right? Because they are linear, so it's a straight line. Okay, so it's really straightforward. And then we know AD maybe D because maybe D point locates above or underneath, but now we know it is underneath. So AD, the length of this arrow, will be the scale length of your linear acceleration at D point, right? So how to do that? Really easy, right? AP over AP prime is equal to 120 over 40. So AP is 3 times than the AP prime. And then now, because we have two similar triangles, so we can see like PO, O point is the IC, right? P prime O is equal to X, while PO is 3X because it's 3 times 3 multiplied by PO, right? So X plus 3X is the whole length of PP prime, which is 15 inch, right? And then X equal to 3.75 inch. Okay, by this we can know that PO is equal to 3x is 3.75 times 3 equal to 11.25 inch, while we already know DP point is only 10 inch only, so it will locate below the instantaneous center O. Okay, and the distance between D and O, which is DO, is simply by PO minus PD. PO minus PD, and it is 11. 25 minus 10 is equal to 1.25 inch only, right? So there is another similar triangle, right? So DO some point is similar to DPAP, right? DOAD is equal to POAP, similar to this triangle, right? And if you use the same rule, so AD over AP, right? Linear acceleration at D point over linear acceleration at P point is equal to something we don't know. We need to get this. This is what we require. And AD over 120, right? This is 120. And it's equal to OD over OP. So it's 1.25 over 11.25. So AD will be 1.25 over 11.25 times 120, and it's 13.333 inch per square second. And then we notice that it is exactly the same as the solution manual that provides on blackboards, right? And then now we know this AD, because it's only in this direction, so that should be transverse direction, right? It doesn't point to the rotating center, right? So this direction will be transverse. This direction pointing to the rotation center. The center of the rotation will be the normal. So now we have to get a normal direction. And what can we do? Really, really easy now. By using the equation, right? Because the normal acceleration will be the equation, right? Normal components will follow the equation omega square r, or it's equal to v at some point square over r, right? So we can get velocity at D point and over dp, and then we get the normal acceleration at D point, right? So to do that, you basically can follow the same rule, the same method given by the solution manual in the blackboards, but you just transfer this alpha letter to v, right? So velocity p equal to velocity p prime equal to velocity p prime, and then the other question you do it again, velocity p equal to velocity d plus omega, which is the angular velocity, right? Angular velocity times rpd, right? doing the same thing, but now because you have the solution on the blackboard, so I don't explain it again, and I still use my second solution to get the velocity, right? Because the velocity is always in the transverse direction, so we can still use the geometrical approach. All right, this is my own solution. So Vp prime is equal to omega A times Ra, and is -4 because A is negative clockwise, yeah. -4 times 5 inch is -20, so it's going to the left, and with a length Vp like this is 20, right? And then Vp is equal to omega B times Rb, and then it's 1 times 20 is also 20. Now we find that this is not just a similar triangle, that's exactly the same triangle. Like these two triangles are exactly the same. Okay, so things now. So the instantaneous center for velocity, I notate it as O prime, right? So P prime O prime is equal to P O prime is just 15/2 because they are exactly the same, right? And then D O prime, because D O is 10 inch and is longer than 7.5 inch. So now we know the D point is located above the O prime point, is here. And then the distance DO prime is 10 minus 7.5 is 2.5 inch here. And then so VD, which is the length here, the bottom line of the triangle, right? VD over VP prime is equal to 2.5. 2.5 is the DO prime length over P prime O prime. Alright, so it's 2.5 over 7.5. So VD is equal to 6.667, which is 6666666, but it's just 667, right? So if you have solution manual, and then you can find my number is again exactly the same as the solution manual. I think it's here. Yeah, right. So it's 667 inch per second, exactly the same. Okay, so now we get a VD, and we just simply use the equation of the centrifugal acceleration, and then it becomes VD squared over RD, and we get 6.67 squared over 10 is 4.44 inch per square second. And then we use the square rule, AD transverse square plus AD normal square and open root. You get the resultant. This number should be larger than any number of ADN or ADT, or you get it wrong, right? So you have to think thoroughly in the exam while you're doing these questions. So now we jump to question 3. Question 3 is here. Okay, pulley A rotates with the angular velocity and angular acceleration shown, and determines the acceleration of block E, right? Block E at the instant shown, right? Again, at the instant, so you have to use instantaneous. It's recommended for you to use instantaneous center, right? And on Tuesday, I say I don't really know whether this small pulley is fixed with the larger pulley, or these two pulleys are free rotation to each other, they separate each other. But now I think they are fixed, right? By reading the solution manual carefully, right? So now let's see what can we do in the first step. Okay, I just follow the solution manual, and you can also use my solution, which is a geometrical approach, to get the transverse acceleration, and you will see how they work, right? So angular velocity, since the pulley A rotates about a fixed axis, right? So angular acceleration, velocity. The velocity is defined by the rope, because this rope is the only connection between A and C point, right? There is a C point. So VC is equal to omega A times RA, which is 40 times 0.05 meter. This is millimeter. Be careful, right? So it is 2 meters per second. Okay. And also, because the rotational motion is defined by these two cable, so we can define, and because it's cable, right, this cable is stationary, right, relatively, it's pretty much like a rack in the first question, right, this cable is stationary, so we can define the IC as the contacting point between this cable and the pulley B, which is here, right. That means at this instant we can draw at this instant we can draw a imaginary trace of CIC, right? This member and remember this line will rotate along my ball pen trace like this instead of like this. No, right? So it will rotate like this. So at this instant, omega B, which locates somewhere between C and IC, so they share the same angular velocity, right? Any point here should have the same angular velocity. So omega B is equal to VC over RCIC, and is equal to 2 over 0.175175 here, right? Ignore my question mark here, right? And it is equal to 11.43 rad per second. This is the angular velocity at any point, not any point, like angular velocity at any point between CIC, right? But if it is the linear velocity, then it is not the same, right? Because the linear velocity is defined by the triangle again, like this, right? So the linear velocity at IC point is 0 because it's instantaneous center, has no velocity, no acceleration, right? And then the acceleration of angular acceleration and angular acceleration of for pulley A, and because the pulley A is alpha A times RA is equal to 0.25, and then it pulled the only cable connect to C, so AC in transverse direction, right? It's transverse, and normal is pointing to the rotational center, which is the IC, right? So transverse equal to alpha A, transverse C is equal to alpha A times RA equal to 0.25 meter per second square. This is a velocity, so AC here is 0.25 meter per square second. All right, and using the results and apply the relative acceleration equation to point C and D to refer by figure B. So figure B is here, right? So what they do, they just noted D point as the instantaneous center again for this point, right? And what can we do? It's about, so AD alpha D, not alpha D, is angular acceleration. No, linear acceleration at D point is equal to linear acceleration at C point plus blah 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 blah. This things is really confused. On Tuesday's tutorial, I say I don't really understand this, but now I see that. So they only care about AD and I in I component, AD normal in I component, but actually these things should be 0, right? He didn't tell me, but because it's the instantaneous center, so these things should be 0, right? And by figure B, acceleration here is 0. That means you draw a triangle again connecting the tail of the acceleration at C to D, because D acceleration is 0, so it is the end point of the this is what do you call it, a corner of the triangle, right? So the triangle look like this. Okay, and so we know that at C point we have a normal acceleration points to the instantaneous center at D, and then there's a transverse acceleration goes up, right? And then we can, and we know the number by previous step. Okay, so that means AD and I, which is 0, is equal to, so that means I should rewrite it. AD and N should, so N component is normal component, should always point to the instantaneous center, right? So it's the only thing is just the, so ADN should equal to 0. So it is ACN minus omega B square over times R CIC. Alright? And that means ACN, the normal acceleration at C point, is equal to the centrifugal acceleration, right? This equation is nothing different, but just another form of V square over R, right? VB square over R, RCIC, right? And AD transverse in this direction is also equal to 0 and is equal to 0.25 J because it is ACT, right? ACT, we already know that is 0.25 J, and plus alpha B times R CIC. Right, so you have two components of acceleration D, but acceleration D, both components should be 0. Right, so after that, the final equation will look like that, like this. This should not be I component. There should be a resultant acceleration at D point. Right, so you have both I components and J components. Right, so J component, which is the transverse component, is equal to 0.25, which is ACT, minus, because it rotates clockwise, so it should be minus 0.175, which is the length, times the angular acceleration B. Alright, and the I point is ACM minus omega square times R. Right, this is the ICN, this is the ADN, this is the ADT. Alright, and both terms should be 0. Okay, so now we know that ACN is 22.86 going to the right because it points to the instantaneous center, and alpha B by this equation, right, this is 0, so by this equation is equal to 1.43 rad per second square. Okay, so after that, we can get acceleration at E point, right? Again, the acceleration at E point should also have normal and transverse. Normal and transverse, like this, right? So AE normal, AE transverse, right? Normal will be I components in X direction. So it should be AC normal AC normal minus the omega b square times r CE, right? So omega b times RCE is actually omega b times RCD minus, so this is actually equal to omega b square RCD, the whole length of the axis, minus omega b square RCE, right? This is the relationship. It's just simply subtract one component and then you get another component, right? But remember this, omega b square, it doesn't follow the linear relationship anymore, so you cannot use the linear geometrical approach, right? Because we just draw a straight line connecting the ACT and the D point, so it is linear. And because this is the non-linear case, we cannot use the geometrical approach. And AET, which is the transverse direction in y direction, right? So it is equal to ACT plus ACT plus, I think that what is that? Yeah, alpha b r CE, right? Because it's a reference to the E point, so it's CE. Okay, and that's it. We have two components, so we have two components of transverse and normal, right? So this part will be this, right? This equal to this, and this equal to this, right? So you have two components, transverse, normal, and they both should be equal to 0. No. At E point is not 0, right? So it's not 0. At D point it should be 0 because it's the end of the triangle, right? It's 0. It has no length. But at E point, you have a small length in this triangle, so it is not 0. Okay, so this is how you should understand this equation. I know it is a little bit confused, and it also confused me on Tuesday tutorial. And by the second solution, right, we can get the J components of the acceleration really easily. I just verify my solution here. So this will be ACT, which is 0.25, right? This is 0.25, and this will be C point, this will be a D point, and here it should be a E point, right? So CE 0.125, CD 0.175, right? So that means AET AET over ACT is equal to, this will be 0.05, right? Is equal to 0.05 over 0.175, right? And this is also equal to, because ACT is 0.25, so it is AE AET, right? So we can get AET is equal to, let me just verify by my calculator. So it's 0.05 times 0.25 over 0.175. Okay, let's see whether it's the same thing. Yeah, it's exactly the same, right? So it's 0.0714, 0.0714 J component, right? Okay, so can we use this geometrical approach to get the normal acceleration? Because we know the normal acceleration, right? ACN is equal to omega b square r cd, right? And this should be omega b square r ed, right? So we cannot use this relationship because it's non-linear. But if we know ed, let me check whether it can be used. So it's 0.05 times times omega b. Omega b is 11.43 square, and then it is 6.53. So it is not the same as 16.33, right? So you cannot really use this approach to get a normal component. Yeah, I confused myself again because this is not 0. That means 6.53 here is also possible. Yeah, but basically I'm convinced. I have confirmed that you can use the geometrical approach to get the transverse directly, and I may explain it in my tutorial section whether you can use the geometrical approach to get a normal. I will study more about this, right? So see you next time. Thank you very much.